But hey guys, we are doing this assignment right here because I love you so much and gave it to you. And if you just want the odd solutions, then go to Google Classroom and they're there as a PDF. But if you want an explanation, that's what this is. All right, number one, anytime the I portion is non-zero, it's always AC. Surely you can remember that. Number three, let's say we've got an I squared, so we could spin the spinner. 0, 1, 2. All right, -1. So that's 3 times -1, which is -3. Or -3 plus 0i, you should recognize that as Enrico Palazzo. Hey, it's Enrico Palazzo. Integers. It's not a whole number. Number 5, if you can type it into your calculator and actually get a result, then it's a real number. So we'd go complex real. But then really you should recognize that as an irrational number. Please don't call that rational. You will really, really disappoint me. All right, number 7. All right, we could just count to 6. I'm going to count to 6 because I like counting to 6. 0, 1, 2, 3, 4, 5, 6. Remember, that is the answer. -1. That was fun. All right, number 9. I dang sure don't want to count to 71. So we want to think of multiples of 4 at the top, like maybe 60. Okay, then we could go to 64 and then 68 or 72 and count backwards. But I'll just start at 68 at the top. 68, 69, 70, 71. Man, that was fun. Number 11. All right, there's a negative in there. Let me give this thing a field because I forgot to. All right, anytime there's a negative right here, man, that gets missed a lot. It just makes me so sad. I'm up at night worrying about it. All right, well, just pretend it isn't there. All right, so let's count to 7. Let's count to 7. 1, 2, 3, 4, 5, 6, 7. We would end up right there, -I. But then you have to remember that you have that extra negative here, and you apply it to -I. That makes it +I. And now we're all happy because we all got it right. Man, that gets missed a lot. Number 13, I'm going to recopy this right here, -I, and rewrite that as root +36 times root -1. Bring down the net that becomes a 6. You know that, and that's I. All right, and then we put all the pieces together. It'd be -6i squared. You really, really, really need to memorize that I squared is -1. And we get a final answer of +6. Number 15, the complex conjugate. Man, that's easy. The real portion stays the same, and the imaginary portion changes sign. 6 minus 3i. If you multiply complex conjugates, you get a real number. Number 17. All right, I guess we're just going to multiply this one on out. Let's do that once or twice. That'd be 27 minus 6i plus 9i and minus 2i squared. And then that would be 27 plus 3i. That becomes a -1 plus 2. And we get a final answer, 29 plus 3i. If you like the boxes like my daughter does, then hey, do the boxes. I'll present that a time or two. They work just as good. Number 19. All right, I went ahead and multiplied this out. So those like terms would make -I. So I'd get 2 minus I. That becomes -1 plus 28 and 30 minus I. I believe I do have this in boxes again. Let's look at it if you want to. If you like the boxes, use the boxes. Doesn't matter to me. All right, 21 is just an addition problem. Remember, when it says simplify, you got to kind of know what to do. And so those like terms right there make 3. And then that one doesn't have a like term with it. It is lonely. So that would be plus 8i. 3 plus 8i. Moving on. Number 23. I mean, just multiply this as if they were polynomials. They're not, but, you know, they have some of the same properties. So that's -32i minus 8i squared. And that'd be -32i. That becomes a -1 plus 8. Keep in mind, at Socrative, when you're typing these in, you have to put them in standard A plus BI form. And so this would have to be written as 8 minus 32i to be in standard form. Standard form, standard form, standard form. No spaces, please. Number 25. That's just subtraction. If you need to distribute a -1, then distribute a -1. That'd be -4 plus 27i. Then standard form would put the -4 first and then plus 25i. Man, you can do that. 27. That's just addition. That's just like terms. That and that are like, and they make 0. This and this are like, they make plus 33i. And you could put it in at Socrative as 0 plus 33i, or you could just put 33i. It's coded both ways. 29. All right, I went ahead and expanded the binomial, for lack of a better word. It's not a binomial, we'll call it that. And I think I'll just present this one with the boxes and give you the answer if that's going to be okay. That looks right. You can multiply that out. I have faith in you. Number 31. All right, this is just addition and subtraction. Let's rewrite it without any parentheses. I mean, if you want to distribute a positive 1, you can, but it serves no purpose. So we get all of that. And then, all right, minus 4, minus 5i. Distribute the negative 1 if you want to. And then our like terms are here. They make 1. And these like terms make negative 6. That looks correct. I think we've got 2 more. All right, I went ahead and multiplied this stuff out, and then I'm going to distribute that negative 1, or distribute the negative. And then we just have like terms. I do need to simplify that to be a negative 1. These 2 terms cancel, so I get 9 plus 25 minus 9 plus I. The plus 9 minus 9 cancel. That was nice. 25 plus I looks correct. All right, guys, I think we have one more, and then that'll be it. All right, I went ahead and made this I to the third negative I. I don't know if I've multiplied it out. No. So let's grind this one out. So that'd be negative 21 plus 12i plus 35i minus 20i squared. Those 2 terms make 47i. I'm going to bring down the negative 21. I'm going to make that negative 1 and then plus 20. So this looks like negative 1 plus 47i. All right, guys, that was a whole lot of fun. We'll do it again another day.